So, what's a long term outlook for the industry? Let's talk about current and long term industry trends and how the industry is being changed and reshaped very rapidly. It used to be when I first started my career that the electric utility industry was a pretty sleepy industry. You'd have a job for life. When you got into the business, your load would grow maybe 1% per year, pretty steady, but perhaps not. Perhaps it would be flat, but you'd have these long term power supply contracts that would maintain the level of expense you would have or make it more predictable, rather. And then we got to the 1990s, and a number of states passed what we call open access rules. In other words, where you as a customer could buy your electricity from any provider, and the local provider that you were buying it from had to provide the pathway, the wires and meters to get it to your place of business or your home, and then you would pay that new supplier as well. Well, that involved moving large amounts of electricity from region to region, and what happened then is that we discovered that the transmission system was vastly undersized. And there were a couple of hot summers there. Power, not a lot of outages, but power was rationed a bit at that point in time. And so what happened then is a lot of the states rather that were going in that direction of open access put the brakes on. But it was a wake up call for the industry that a lot of work needed to be done to provide reliable service. Now, there still are states that have open access for customers, but the next wave of change is with renewable energy. So, renewable energy resources are rapidly changing the business, but at this point in time, renewable energy, which is good during the daylight hours for solar and wind, the necessary battery capacity is not quite there yet in order for it to be used when the sun goes down. And also, solar and wind are not great baseload supply sources of electricity like our fossil fuels are and those types of plants. So the whole industry is in flux. We are kind of overbuilt on the generation side. Sometimes, if you have a high level of renewable energy resources, you need to have a backup for those. And eventually, if things play out the way they look like they will, that will back off and battery power will be more reliable. We'll be able to retire some of those older plants. But in the meantime, there's a lot going on in the industry. So the debate isn't whether the industry will change, it's how fast, and who pays for it is a big factor, and who has the expertise to manage it. So the grid needs trillions of dollars in order to be upgraded. We have a fleet of power plants that either need to be retired or replaced. And we have a new source of electricity, renewables, that are trying to fill the gap. So all that is going on. It's a fun business. It's a great business to be in. And those forces that are reshaping the electric utility also include electrification. So we see more transportation, electric vehicles, home heating, industrial processes are moving from fossil fuels over to electricity. So when we see new building units going up and things like that, there's more electrification. And just think of society without electricity. It would be not quite as fun as it is now. And so electrification is putting greater demands on the business. Renewable generation, I talked a bit about that. So the rapid growth in solar and wind and retirement of fossil fuel plants is accelerating, but they are not quite on par with fossil fuels yet. Headed in that direction. Hopefully we'll get there sooner rather than later. Battery storage gets better exponentially every year, but still is not to the point where it can fully replace fossil fuels when the sun goes down. But battery capacity is like the hockey stick when it comes to more battery capacity year by year. Distributed energy resources, we see customers owning their own solar, batteries, and electric vehicles that are more active participants in grid supply planning. So when we do long range integrated resource plans, actually there's a FERC order that says you need to incorporate your distributed energy customers in that plan, because earlier on it was hit and miss over what city had how much, who had it, what pockets, things like that. It's becoming a bigger force in energy planning. Then grid resiliency and cybersecurity is a big issue. The grid needs major rebuild and upgrade in order to meet the electrification needs that we have as well. And so that's a big factor. And then workforce and infrastructure, as we talked about, not only are we replacing aging grid assets, we're replacing aging line workers and other operational folks. And so we need a pipeline of individuals for the next generation to take over the business, as well as the next generation of the grid. So when you look at the transformation in context, I like to think about it as the utility of today versus the utility of the future. And we'll go category by category here. On the generation, today we have centralized large plants, coal and gas and nuclear. And in the future, we'll have a mix of distribution. We'll have renewable energy. We'll have what we call microgrids, which are pockets of customers that band together to acquire electricity and disconnect from the native system, which they were getting electricity from before. So you see a difference in generation. The grid flow one way from the power plant to transmission to the customer, where now we're going to a two-way grid where customers also have generation and are selling it back to the utilities and co-ops. Metering was the basic meter reader, go out and read the meter, and your bill is based on that. Now we have smart meters that have real-time data. We call those AMI meters. And so you can do a lot with these smart meters besides bill customers. Customers can manage their own use, and you'll see a lot more uses of that. Customer roles, where customers are fairly passive, pay what you charge me for that. Now we see more activity with customers being power suppliers with distributed energy resources, electric vehicles, smart devices. The workforce skills, they physical and traditional skills were physical, field-heavy trade skills, but there's more technology now and in the future coming that will make that job easier. But there's still going to be a very physical component to the field crews that keep the lights on and keep the system up and running. And then rate design was fairly simple today. Up until today it's fairly simple, but going in the future you'll have the ability to have time of use rates for all of your customer classes. You'll have the ability for what we call demand response. When energy usage is high and you need to back it down, you'll be able to work with your customers to do that. And that will drastically change our power supply focus and how we plan for the future. So the things that carry forward from this segment are the industry is changing. That makes it fun, makes it interesting, also makes it challenging as well. And without a doubt, the demand for electricity will continue to grow. We're electrifying our society more and more in a number of areas: transportation, heating, and industry, and we need to develop resources to meet that transformation. Distributed energy resources, so customer solar, customer wind, are shifting customers away from being passive to active grid participants, and FERC has recognized that and ordered utilities to incorporate that into their power supply planning. And we always need people, so the industry needs people with deeper technical skills, not only the physical skills, but in those vocational programs, more and more technical approaches are being taken on how we can have technical field tools to make the construction process easier. There'll still be a big physical component to that, but the line worker of tomorrow needs to have deeper technical skills, and the training is going in that direction.